Hello everyone, welcome to solve this math Olympiad algebraic challenge, and here we have 5 to the power of n minus 3 to the power of n equals 544, and we solve this problem for the values of n. So in this question we use the reverse engineering method to solve this problem, and I hope so you like this method. So here the very first step we are going to do is here first we take the base of this term is equals to a, so we take a equals to 5, and we take the base of this term equals to small b, and we have b equals to 3. And after that we just substitute these two values on the above equation, so that our above equation will be written as a to the power of n minus b to the power of n equals to 544. So after that now we focus on these substitutions which we take a equals to 5 and b equals to 3. So here we take the square on a on both of the sides, and we obtain a square equals to 5 square, and when we take the square on b, then it will becomes b square equals to 3 square, and we call this as equation number 1. So here when we simplify these two values, then you get here a square equals to 25, and we get b square equals to 9. So when we subtract these two values, then it will becomes a square minus b square equals to 25 minus 9, and we know that 25 minus 9 equals to 16, and we call this as equation number 2. And similarly here first we subtract a square and b square, and now we add a square and b square. So when we add a square and b square, it will becomes a square plus b square equals to 25 plus 9, and we know that 25 plus 9 equals to 34, and we call this as equation number 3. So here we copy down equation number 1, and we have equation number 1 is a to the power of n minus b to the power of n equals to 544. So then we copy down here from equation number 1 we have a to the power of n minus b to the power of n equals to 544. So in equation number 1 we just focus on the right hand side of equation number 1, and right hand side we have 544. So now first we find the prime factors of 544 by using this division method. So we have we first divide it by 2, and we have 2 2s are 4, and we carry 1, 2 7s are 14, and 2 2s are 4. Again we divide it by 2, and we have 2 1s are 2, 2 3s are 6, and we carry 1, and 2 6 are 12, and we again divide it by 2, and 2 6 are 12, we carry 1, and 2 8s are 16. So 2 3s are 6, and 2 4s are 8, and here we have 2 1s are 2, and we carry 1, and 2 7s are 14, and now we divide it by 17, so we get 17 1s are 17. So here you see that we have these are these are 4 times of 2, and we multiply these are here, and we write it as 544 equals to 2 to the power of 4 multiplied by 2 multiplied by 17. So we know that 2 to the power of 4 equals to 16, and 2 times of 17 becomes 34. So now we substitute this 544 equals to 16 times of 34, so that our above equation will becomes in this form: a to the power of n minus b to the power of n equals to 544, and we replace 544 equals to 16 times of 34. So after that, we focus on equation number 2 and equation number 3. So in equation number 2, we have the value of a square minus b square, it is equals to 16, and in equation number 3 we have the value of a square plus b square, it is equals to 34. So we substitute the value of 16 and 34 here, so that we just write using equation number 2 and equation number 3. So that when we use equation number 2 and 3, we put the value of 16 and 34 here, and we obtain a to the power of n minus b to the power of n equals to 16 equals to a square minus b square, and 34 equals to a square plus b square. And now we focus on the right hand side, and we have a square minus b square into a square plus b square. So this equation implies that a to the power of n minus b to the power of n equals to a square and its whole square minus b square and its whole square. So here we know that a square and its whole square will be equals to a to the power of 4 minus b square and its whole square equals to b to the power of 4. And now we compare both of the sides, and you see that by comparing we get a to the power of n equals to a to the power of 4, and we get b to the power of n equals to b to the power of 4. So here you see that we have bases on both of the sides are same, so we equate its exponents. So here we get n equals to 4, and in this case we compare and we get n equals to 4. So on both of these cases we get the value of n equals to 4. So this is the final value of n, and now we verify these values, and for verification we again copy down the given question statement. So our given question statement is 5 to the power of n minus 3 to the power of n equals to 544, and now we substitute the value of n here, and we get 5 to the power of 4 minus 3 to the power of 4 equals to 544. So we know that 5 to the power of 4 equals to 625, and 3 to the power of 4 equals to 81, and this whole equals to 544. So it will be equals to 544 equals to 544. So this shows that n equals to 4 satisfied the given question statement, and n equals to 4 be the only solution of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.